Hello, everybody. It's Michael Antonio, and welcome to Advanced CDK Techniques. This channel is for users who are familiar with the AWS CDK and want to create more powerful infrastructure as code solutions. If you're new to the AWS CDK or infrastructure as code, we recommend the CDK Live channel. See the link in the description. Today's topic, tokens, tokens, tokens. Okay, so I'll be using my CDK orchestration library today for this demo, and the code for this lesson is checked into CDK orchestration examples in GitHub. I'll put a link to those in the description, as well as a link to the tokens documentation in case you want to dive even deeper into tokens. Not token, tokens. We'll get back to you later, Professor. Okay, now this is a perfect example of a token. This is a silver certificate, and you can see that it looks a lot like a dollar bill, but it's not a Federal Reserve note. These were used in my grandparents' day, and it says here, this certifies that there has been deposited in the Treasury of the United States of America one silver dollar payable to the bearer on demand. So if you had a silver certificate with the blue seal and the blue numbers and you took it to a bank, they would give you a coin that contained $1 worth of silver. And they did this because they knew that they could give that bill to the federal government and get their silver back. So you got the actual metal. You would give the bank one set of atoms, and they give you another set of atoms. Okay, so now what are CDK tokens? Well, CDK tokens are objects that can be used as a string. It could be an object or a number, and it represents a value that will be produced later on at synthesis time. And that value that will be produced will be a string, a CloudFormation snippet, or a number. A good example of this is the AWS region constant. This is a CloudFormation intrinsic variable, and if you reference this variable in your CloudFormation template, it will get resolved at deployment time to the actual AWS region that you're deploying into. Now, if you print the AWS region token, you're going to get kind of a strange string. It starts off with this $sign, and then it's got this bracket. It says the word token, and then it's got a square bracket, and it's got those again at the end. And this is basically the part that tells the CDK that, oh, this part of the string is a token and it needs to be resolved before we write it out to the template.json file. This part here where it says aws.region in the token, that's the hint. And that gives you some idea of what maybe this token represents and what it will be resolved to. And the 10 just says that this is the 10th token that has been created, and therefore that's where we need to look up in the resolution table, and that's CDK internal. And these are resolved and synthesized by calling a produce function, and they're written to your template file as a CloudFormation intrinsic function call. So here the function is ref, so we're calling the ref function, and you can ref a lot of things in the CDK, and here we're referencing this internal intrinsic variable, and that will resolve to the AWS region, which might be, for example, US West 2. Okay, so CDK tokens, there are different types of tokens. Stable tokens always return the same value. So if it's a string, it always returns the same string. That value is cached by the CDK. And this is why you never call stack.resolve. The token might not be resolvable yet, or it might resolve to the wrong value, and I'll show an example of that. There are uncached tokens, and with uncached tokens, the CDK will call the produce function every time it needs to write the value of that token to the template. And the CDK will pass a context, and the uncached token can return different values based on the context, and I'll show you an example of an uncached tokens. There are also intrinsic tokens, like the AWS region token I showed you. There's also the fnjoin function, which produces intrinsic tokens, and intrinsic tokens are tokens that resolve to intrinsic functions, but they could also resolve, for example, to strings, and I'll show an example of that. And usually they resolve to CloudFormation statements, but not always. Okay, so a quick tour of the CDK token lifecycle. Tokens are created at create time, which is when you create your app, your stacks, and your other constructs. They can be created other times, but usually it's at creation time. And tokens are usually resolved at synthesis time, unless, of course, you happen to resolve them at create time, which, again, not a great idea. Um, when the CDK generates the CDK out directory with the CDK templates and code. That's synthesis time, and that's normally when tokens are resolved. Okay, and it's demo time. Let's go take a look. Okay, and I have all of the output here, so we can just take a look at this. There we go. Okay, so I tend to take my lessons and put them in stack form. So here's a stack. If we go to the main, you can see here I'm creating the stack. I created my app construct. I added a service inspector aspect to it just for fun. And now I'm creating my stack, which is tokens, tokens, tokens. So when we come over here, you can see I set up a little bit of logging, and we're going to log out tokens, tokens, tokens. So that's the lesson name. And then we're going to log out bucket names and tokens next. Okay, so tokens are objects that can be represented as a string, can be part of a longer string when necessary, and are resolved at synthesis time by calling the produce function. So a good example of a token is the bucket name property. And let's take a look at how the bucket name property works. So we're going to create an S3 bucket, and it's going to be called unnamed bucket. And that produces in my template.json file a resource where the logical ID of the resource is unnamed bucket with a hash after it. And you can see I passed in the bucket name as undefined. Now, bucket name is optional, so I could have just not passed it in at all, and then the default value for it would be undefined. And in fact, bucket props are optional, so I didn't even have to pass that in. And when you don't pass any properties to a bucket, or they're all undefined the way that they are here, then you end up with a bucket in your template with a type of AWS S3 bucket with this update replace policy and deletion policy. And these are here just because it's an S3 bucket. Those would be the default values for an S3 bucket. You can change those if necessary. And you'll see that there are no properties here. So there are no resource properties listed. There's only metadata. And this metadata, you can see that it's telling us that the stack is tokens, 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 that the construct, the L2 construct, the bucket construct is unnamed bucket, and that's the logical ID, or sorry, the construct ID of that construct node, which is a child of the stack tokens, tokens, tokens. And it has a child, which is an L1 construct called resource. Normally for L2 constructs like a bucket, the L1 construct, in this case, CFN bucket, is given a construct ID of resource. Okay, and so that's basically how you can create a bucket. Okay, so now when I create a bucket that way, what do I get for a bucket name? Because obviously I didn't give it a bucket name. So let's log out the bucket name. So I'm going to log it out, and I'm going to call it unnamed bucket name ref, because this is not the name of the bucket. This is a reference to the bucket name. And it gets printed out as a token because it is a token. In this case, it's a 21st token that was created. It is not resolved, and I just printed that out here just to see if this is a resolved string. This token is unresolved will tell us if a string needs to be resolved or not. And when I resolve it against the stack, I'm going to get a value of this CloudFormation JSON snippet. And this is a call to the ref intrinsic function, and it's referencing the logical ID of my bucket, and that always returns the bucket name. So that's why bucket name returns this particular token. And so that's just one way that you can reference the bucket name. Now, since I didn't give this bucket a name, S3 is going to generate a name at deployment time, and this is how I can reference a name which does not exist yet because it has not been generated yet. I can use this little JSON snippet here to reference that. Okay, so buckets can also be named with constant strings. And so here I've created a constant string, and to make it unique, I put in my AWS account ID and the region. And that should be enough normally to make your bucket name unique. And so I'm going to pass this to this bucket. So I'm creating a bucket called static name bucket. You can see that it ends up with static name bucket with a hash. And it has the same type and policies that this bucket did here because it's an S3 bucket. But this one actually has properties, and the bucket name property is set to a string, and it's set to the string that I set it to, which is static named dash my account ID, which of course is a dummy ID for the sake of this demo, and dash the region. Great. Okay, so now when we print this out, we're going to get the actual bucket name, right? Wrong. We're going to get a token because, again, bucket name is a reference to the name. It's not the actual name. So, for consistency's sake, bucket name is always printed out as a reference to the logical ID of my bucket resource, which means it's going to resolve to the bucket name at deployment term. So it's really the exact same thing. Now, if I print out the string, well, obviously, it's going to print out the string that I passed as the bucket name. And we're going to say, well, okay, is this string resolved? And the answer is yeah, that string is resolved. Okay, you can also name a bucket by calling fn join. And what this will do is you pass it a delimiter, and then you pass it a list of strings, and that is list of values here. That's what it's called. And I can pass in the AWS account uh, intrinsic variable because that is a string token, and region is also a string token. So I can take these four strings and pass them to fn join. Let's see what we get when we do that. So here it is. If I take a look at my join named bucket, it ends up with join named bucket with a hash as the logical ID, and the bucket name is not set to a string. Instead, it's set to the CloudFormation intrinsic function fn join, which returns a string. And as you can see, it took the exact same join that I made over here, where I had a delimiter of dash, and then the first parameter is join. Oh, hold it. The CDK was smart enough to know that join dash named, you can do this part of the join at compile time. So it's basically saving the CloudFormation service some work by doing that work at compile time. So that's kind of nice. They put join dash named here, and then they put the two intrinsic function calls, one for the account ID and one for the region after that. And so this will resolve to join dash named dash my account ID dash my region, very similar to the static name bucket that I did above. Okay, so when we print out the bucket name for the join name bucket, we would get the same thing that we got above. Here, I'm going to print out join name, and you can see that instead of printing out a string, a normal string, it's printing out a token. So this is entirely just one token that I get when I call fn.join, and this token here has a hint of fn : join because I called the fn join function, and of course it's not resolved. And as I said, when it's resolved to this CloudFormation snippet here. Now that's really interesting. We have a string token that resolves to not a string, but it resolves to CloudFormation. So how would you actually do that? How does that work? It produces a CloudFormation snippet. It does this by using an any token. So in order to create tokens, you use the lazy class, and the lazy class produces a lazy value, which is one which is calculated later during synthesis, meaning that it's a token. And so lazy.any has a producer that can produce any value. So for my version of join, what I'm going to do here is I'm going to have a function that, again, it takes a delimiter and it takes values, which is a string array. And for every value, what I'm going to do is I'm going to say, is that value resolved? And if all the values are fully resolved, then I can do this join at compile time. So this is a little bit simpler than what fn join does, but I think this will give you some idea of how you would actually write a token like fn join. And so I can return a string if everything's fully resolved. Otherwise, I'm just going to return an fn join statement that has the delimiter and the values that were passed in. And you can see down here in my oh no, I'm actually just printing this out. So I'm going to create uh, a, a produce function by calling myJoin, and this produce function, or actually this is a string here. So this string I'm going to call myJoin. I'm going to pass the delimiter. I'm going to pass all strings resolve. We're going to print that out. We're going to see that says token myJoin 50, and that's because I passed a display hint of myJoin when I created um, my lazy any, and then I had to take that any, which is returning an iResolvable, and I have to turn that into a string, and that's when I also pass in a display hint of my join. So you can see I just passed in the display hint twice. So if you're looking either at the any or at the string, you're going to see that. So when I printed it out, you can see that it says myjoin.50. And then when I resolve this token against the stack, you can see that it printed out all strings resolved. So here's an example of calling myJoin and getting a string. Now, if I instead resolve a join where some of the strings are resolved and some of the strings are tokens, then we're going to get an fn join, and here we're going to get the fn join exactly as I wrote it instead of using the method that the CDK does here, where it's just a little bit smarter about it. So with the CDK, it would have been some dash strings dash resolved and AWS account ID. With myJoin, it's just a little bit simpler, so it does it this way. But you don't actually have to call join when you're naming a bucket. You can create an implicit join name. And you do that by creating a string that has constant parts and token parts all in the string. So when I create an implicit join named bucket, here I'm going to call it implicit join named bucket. It's going to end up in my template right here as implicit join name bucket with the hash. And the bucket name is an fn join. Now, when you do an implicit join, the delimiter is always the empty string. That makes it easier for the CDK. And then the CDK takes the constant parts and writes them out as arguments to fn join. And it takes the um, token parts and it writes them out as CloudFormation because these tokens happen to resolve always to CloudFormation. So there you go. That's how you can name a bucket with an implicit join. Okay, so now let's take a look at creating our own tokens. Okay, we're going to create some stable tokens, and here I'm passing a produce function to lazy.string. So you have to pass it a producer, a stable string producer, and you can also pass it a display hint. So when I don't pass a display hint and I tell it to produce a value, and this could be a calculated value, this could be referencing a variable in this stack or in a construct, and it would resolve whatever that value was at um, uh, uh, synthesis time. And so I'm able to write this out, and you can see that it writes it out as a token. And here I'm going to also create a lazy string, and I'm going to give it a display hint of spider. And this one is going to be printed out with a display hint of spider. And so that's kind of nice that if I produce Ungoliant and I take a look at this, now I can see that, hey, there's a spider in there. So when this is resolved, I'll get the name of a spider. Whereas with this one, I didn't know what the value was because the hint is not very helpful. Now, when I resolve this token, I'm going to resolve these stable tokens. I'm going to resolve them in the stack, and I'm resolving this one to Shelob, and this one resolves to Ungoliant, pretty much what you would expect. Uncached tokens are different. So here, I'm going to create a region token, and it's going to be an uncached string. And when I produce a value for this token, I'm going to get a scope. Again, that could be a CFN element or a stack. And I'm going to get the stack of that scope, and then I'm going to return the region. So my display hint here will be region. And when I print out this uncached token, I'll get a string that has token and region.66, and that will just tell me that, oh, there's probably either a region string or a reference to the region or something like that in here. Create these two stacks. This stack is going to have the name of this stack, which is tokens, tokens, tokens dash Valinor. That's going to be the name of this stack. And this one is going to be tokens, tokens, tokens dash Baleriand. And the Valinor stack is going to have a region of US East 1, and the Balerian stack is going to have a region of EU West 1. So let's go ahead and resolve this uncached token in the Valinor stack. And what I get when I do that is I get US East 1. And when I resolve it in the Balerian stack, I get EU West 1. And that's pretty much what I would expect here because of the way that the produce function was written for this uncached string. So we can get different values out of the same token in different contexts. Now, if I use the AWS region intrinsic token and I resolve it in the Valinor and Balerian stacks, I get the same thing. I get ref AWS : region, which is pretty much what you would expect from the CDK. And in this case, it can have AWS region as a stable token. It doesn't have to be an uncached token, and that makes things a little bit more efficient for the CDK. You can also have complex intrinsic tokens. So in this case, I'm passing the AWS region to get AZs. So get AZs takes a region. If you don't pass it a region, then it will actually default, I believe, to AWS.region. And so I'm getting this complex token here, which when I print it out, it's going to just print out as token. And then I'm going to resolve this complex token in the Valinor and Balerian stacks. And here you can see that it's a call to the intrinsic getAZs function, and it's passing a call to the ref function referencing the AWS region intrinsic variable. Okay, so let's do something now with tokens that you couldn't do with just a string, because obviously for some of the things that I've created here, I'm just resolving to a string, and that's not very exciting. So here I'm going to have a token called allStacksProducer. And allStacksProducer, this is just the producer that I'm putting into this variable, and the produce function of this is going to use the stack utilities class from CDK orchestration, and it's going to call stacks. And stacks is a function that returns a list of all the stack construct descendants of the scope. So it'll search the entire tree and return all of the stacks. And so here I'm passing the app, so I will get all of the stacks in the app construct tree. And then I'm going to map those to the stack name, and then I'm going to do a join. So this will produce a string because join produces a string. So that's why this is a stable string producer. It only produces strings, and that string is basically a comma delimited list of all of the stack names. So here I'm going to create a lazy string. I'm calling this some stacks because what we're going to do is we're going to resolve this token right here in the stack tokens, tokens, tokens. So I'm going to create a lazy string for my stable string producer. I'm going to pass the all stacks producer, and I'm going to give it a display hint of stacks. And it will resolve to some of the stack names. And the reason it will only be some of the stack names is because down here, I'm going to create another stack. And that will not be part of this because it's already been resolved. So to give you a demo of this, I'm going to create a function. This is an inline function here. And I'm going to put some stack names in the environment variable, so you can see that. And then I'm going to put all of the stack names in stack names because I'm going to create a new token, a lazy string with the all stacks producer, and I'm going to give it again a display hint of stack. So if you printed out the value of this environment variable um, using console log, then it would print out the token with a display hint of stacks. Okay, so let's see what we ended up with in our template. So here we have a role, and then down here we have the function. So whenever you create an L2 function, you get two resources. You get the role, and then you get the function. So here's our Lambda function. It's got inline code here because I just kind of slurped in the code that was in a JavaScript file that I had in my project. And down here, I am passing the stack names. And you can see that the stack names are tokens, 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 tokens dash Valinor, tokens, tokens, tokens dash Valerian, and then tokens, tokens, tokens dash another stack. And this is because I did not resolve this token until synthesis time. And when it resolved at synthesis time, then I got the values that I expected. Whereas this token here only ended up with 3 of the stack names, not all 4, because I did not, I resolved it at creation time, and I resolved it before the another stack had been created, and that's why that was missed. So hopefully that gives you guys an idea of how to use tokens and what they're for, why they exist in the CDK in the first place, and how you can take advantage of them in your own CDK code. So thanks a lot, everybody, and I'll see you in the next one. Bye-bye.